Assalamu alaikum. Welcome to our lesson Limits and Continuity Part 1. The objectives of our video are: the student should be able to recognize the meaning of the limit of a function at infinity. Find the limit of a polynomial function at infinity. Recognize and use some properties of limits and find the limit of a function at infinity. Before we start, prepare please the following materials: textbook, pens, draft papers, copybook, and calculator. Let's start with activity 1. F is a function defined on R with f of x is equal to x squared. Needed to complete the table below. For each value of x, find its square. We notice that if x is 10 squared, f of x will be 10 exponent 4. For x is 10 cubed, f of x is 10 power 6. Similarly, for 10 power 10, f of x is 10 exponent 20, and for 10 exponent 50, f of x is 10 exponent 100. Let's complete the following statement. When the value of x is very large, the value of f of x is also very large. Here we say that as the value of x increases, the value of f of x also increases. As a result of activity 1, we say f of x tends to plus infinity as x tends to plus infinity. Written as limit of f of x as x tends to plus infinity is plus infinity. Remark: x tends to plus infinity means that x greater than k for any k where k is a positive real number. Example 1. Calculate each of the limits below. Limit of x cubed as x tends to plus infinity will be plus infinity. Also, limit of x5 as x tends to plus infinity will be plus infinity. Application 1. Now let's complete with activity 2. Given f is a function defined on R as f of x equal to x cubed, given many values of x in the table below, needed to find f of x. Let's start together. For x is minus 10 cubed, f of x will be minus 10 to the power 9. For x is minus 10 exponent 7, f of x will be minus 10 exponent 21. Similarly, for the other two values. Here we notice that when the value of x is very small, the value of f of x is also very small. We say that the value of x decreases, the value of f of x also decreases. As a result of activity 2, we write that the limit of f of x is minus infinity as x tends to minus infinity. Notice for some limit of a functions of reference. Example: calculate the limits below. Limit of x3 as minus infinity will be minus infinity. Limit of x5 as x tends to minus infinity will also be minus infinity. Let's now do application 2. Now let's start with another activity. Consider f, function defined over 0 plus infinity, as f of x is 1 over x. Complete the following table. For each value of x, find the value of f of x, which is equal to 1 over x. For x 10 exponent 6, f of x is 1 over 10 6. For x 10 exponent 20, f of x 1 over 10 20. For x equal 10 exponent 50, f of x will be 1 over 10 50, and similarly for 10 exponent 100. As a result of activity 3, when the value of x is very large, f of x approaches 0. As the value of x increases, here f of x tends to 0. And we say limit to f of x as x tends to plus infinity will be 0. So as a remark, constant over plus or minus infinity tends to 0, where c is any real number. As an example, limit of 4 over x as x tends to plus infinity will be 0. Similarly, for the limit of minus 6 over x as x tends to minus infinity will be 0. Let's start now another application. Calculate each of the limits below. Now, let's consider some properties. If f and g are two given functions, k is a non-zero real number. Alpha can designate plus or minus infinity or any real number. The limit of the product of f times g as x tends to infinity will be the product of limit of f as x tends to infinity times limit of g as g tends to infinity. Similarly, the limit of the sum or the difference of f and g as x tends to alpha will be equal to the sum or the difference of limit of f of x as x tends to alpha and the limit of g of x as x tends to alpha. The same cases for the quotient of f and g and for the product of a constant and f of x will be equal to the constant times the limit. Now let's see some operations on limits. Example, needed to calculate each of the limits below. The limit of minus 2x cubed as x tends to infinity will be equal to minus 2 times plus infinity cubed. That is, plus infinity will be minus infinity. The limit of x squared plus 2x will be equal to the limit of x squared plus the limit of 2x, which is plus infinity. The limit of minus 2x radical x will be minus 2 plus infinity times plus infinity, that is minus infinity. And finally, the limit of x5 plus x2 cannot be known because it's minus infinity plus infinity, which is an indeterminate form. As an application, find the following limits.